Hello all, my name is Ryan Wade and I'm here to present to you all how to create stunning visuals in Power BI using the R programming language. Before we get started, I want to tell you about some of the other things that PASS has to offer other than what you all are attending at today, and that is these events such as local user groups. You have SQL Saturdays, which are great one-day training sessions where you have professionals, Microsoft professionals from all over the country going to different locations to share their knowledge about all things Microsoft data platform. And in addition to that, you also have other online offerings that I highly recommend that you take advantage of. It's a great way to build up your not only your SQL Server skills, but skills in other areas in the Microsoft data platform. After this session, we will really appreciate if you will fill out an evaluation. That would be helpful to me and also Pat Summit just to get a gauge of what your thoughts were about the session and ways that we can improve so that we can continue to provide you all with a great experience when you attend Pat Summit, whether it's virtually or if it's on site like it traditionally has been in the past. Okay, so we got that out the way. I'll give you a little bit of introduction about me before we get into the actual presentation. I'm a senior consultant at Blue Granite, and I'm a bona fide data geek. I mean, I love what I do, so learning the new techniques that I will share with you today in Power BI using R, or doing some other things that you can do in the Microsoft data platform. Learning that type of stuff is fun to me. So hopefully some of the things that I've gained, I can share with you all today, and you all will leave this session with some good information and good knowledge. In addition to being a consultant, I'm also a author of a fairly new book that was released in September that is covers some of the things that we will talk about today. And the title of this book, as you can see, is Advanced Analytics and Power BI with R and Python. So if you find what we go over today interesting and you want to do a deeper dive and you want to find out other ways you can use R and Python within Power BI, this book will probably be a good option for you to explore those things. Now, the company I work for, Blue Granite, I'm fortunate to work with a team of very smart and educated people, and they say iron sharpen irons, iron sharpen iron. Excuse that little blip, but at Blue Granite, we're able to deliver amazing solutions to our clients. And one of the things that we're going to follow up this session with is a series of blogs and vlogs where we will do a deeper dive in the topic that I covered today. So if you find today's topic interesting, I highly recommend you check us out at Blue Granite. Now, what is the agenda for today? This is the last of the slides. After the slides, we are going to, go straight demo mode. We will show you how to configure your environment to use R and Power BI, and we will also go over how to configure Power BI. After we do that, we will do a deep dive in the code that is needed to create the visual that we will go over. So with that being said, we can exit these slides and we will go to a data science virtual machine to go over what you need to do to configure your environment. Okay, now the data science virtual machine is a VM that is pre-configured with pretty much all the tools you need for data science type of analytics work. So with that being said, if you've done anything with data science, you know that setting up your environment can be a challenge. You need to install R and R Studio. You need to install the distribution of Python that's very, very popular for data science, which is Anaconda. And there's all kinds of things that you need to install in order to set your environment up so you can begin your development. Well, with the data science virtual machine, it does all that for you. So what will traditionally take you days or even sometimes weeks to configure by yourself, going through a lot of trial and error, you can spin up a data science virtual machine that's available to you in Azure, and you can get that up and running fairly quickly. It takes like 10 to 15 minutes to configure the environment and then get it up and running. So I highly recommend you go that route when you're setting up work to do advanced data analytics that requires tools like R and Python, or you can configure yourself. And I will, in the GitHub repo for this session, I will share, if you decide not to go the data science virtual machine route, and if you want to configure your own environment, I'll show you a way where you can do that yourself, where you know the steps you need to do in order to do that. But if you were to do it yourself, you would need to install a distribution of R, you need to install RStudio and some other tools. But again, in the README in the GitHub, if you need those instructions, they'll be available to you. The nice thing about using the data science virtual machine is that not only do you have advanced data science tools like R, Python, Anaconda, and some of those other tools already pre-configured and installed for you, but some of the setup work that you would need to do in Power BI is also already done for you. So one of the things that you would need to do in order to start leveraging R or Python and Power BI is you would need to go to File, Options and Settings, and then clicked on the wrong one. Sorry about that. It's File, Options and Settings, and then Options. That's the one I meant to pick. And then in this area, when this form pops up, you will see that there's an area right here called R scripting. So what we're going to do in this session is use R in order to create a visualization. So you need to select R, and then if it's not pre-configured like it is now, if you're not using the data science virtual machine, you would need to specify the distribution of R that you're using, and it in most instances will detect it if you already have it installed on your machine, and also the preferred IDE that you want to use for your R development. Now that is going to be important later on, as you will see when you're doing the development of your script, because the IDE that's offered in Power BI is not a IDE that you would really want to do some serious development in. So what Power BI has done is that instead of them trying to recreate a new IDE for R, they said, we will let you use the one that you prefer to use. And the preferred IDE for R is RStudio. So you're able to use that. You'll see that in a second, how that is leveraged from Power BI. Okay, so after you get that basic configuration set up, you probably notice when you have been doing work in Power BI, this R icon over here, and that is for our script visual. And then you also notice the same thing for Python. So if you want to create an R visual, you would set it up in a similar fashion that you do any other visual in Power BI. You will select the icon over here, and you drag it over to the canvas, and you will size that visual in a shape that you want it to be in on your canvas. After you do that, you will need to do just like with any other visual, you will need to supply it with the data that is needed for the visual. And once you do that, you will notice that if you select your R visual, that R script editor will appear at the bottom. Now, one of the things that I like to point out is this right here. On line 4, you notice that it says that it will use the unique function in R to make that data set unique. So that's very important to know, because if you pass in duplicate records on purpose to your R visual, you note that those duplicate records will get collapsed, and that can cause undesirable side effects to happen. So you need to make sure that the data set you're passing to your R visual is unique. One way to ensure that is if you have like some sort of ID field that you can add to your data set, or whatever you can do to make sure that data set that you're passing to R is unique, you need to make sure that you do that. Okay, so now you got your R visual on the screen, you got it sized up the way you want it to be on your canvas. Now you want to start development. And like I said before, this IDE, even though you have a little bit of IntelliSense and it's color coded and all that, it's not an ideal environment that you would like to do your art development in. So, like I said earlier, Microsoft has set things up to where it will allow you to use the IDE that you prefer. And in this case, we prefer RStudio. So instead of having to write your code in this editor, what Microsoft enables you to do is if you click on this 45-degree angle that's pointing to the north, I guess you would call that the northeast, you click on that, it will take the data set that was passed to your R visual and it will launch RStudio. So let's see what's going. Okay, here it is right here. You see that RStudio has been launched. So what happens is it took that data set that was passed through R from to the visual, and it saved that data set to disk in a CSV file. And that data set can be used to be the basis of the visual that you want to create. So what happens is you will get your code functional in RStudio. Once you get your code functional, you just copy everything that's below the paste or type your script code here. Everything from line 10 all the way down. Once you get your script functional, you copy that and then paste it back into your R script editor in Power BI. And the reason why that works is because if you run line 2, which is the line that reads in the data into the data set variable, if you notice, we go back to Power BI, you'll notice that the name of the data set is data set. So if you base your code or if you base your visual on that particular variable, then it will, doing the copy and paste will work. So with that being said, what I would go over now is how to create this visual. So let's take a step back for a second. You're probably saying, Ryan, why would I want to create a visual in Power BI using R? Well, the R community has been around since the 1990s, and it's the R programming language is a language built by statisticians for statisticians, and statisticians, one of the most important parts of their job, is data visualization. Just like data analysts, they need to be able to tell their data story to the consumers of their data. And, so they have been placing a lot of importance to data viz well before a lot of us have in the traditional business community. So they have placed a lot of effort in building packages that make doing data viz relatively easy. And arguably one of the most popular packages to do that is a package called Ggplot. So let me go here. We're going to leave the data science virtual machine, and I'll give you an idea of some of the things you can do with R. So one of the things that we are pretty well aware of is let's look at, I'm looking for, here we are right here. Being in the Microsoft data community, we are well aware of this chart right here, the Magic Quadrant chart. And this chart allows us, to see how Microsoft rates compared to the competitors. And you'll see that in the quadrant chart, it measured two things at once: the completeness of vision, as well as the ability to execute. Now, one of the things I like about the chart that we're looking at right now are some of the subtle features of the chart. You'll see that in this chart, we have a situation where we have each quadrant of the chart labeled. We have the challengers, we have the leaders, the niche players, and the visionaries. And then in addition to that, you have some other subtle features of the chart where you'll see that quadrant 2 and quadrant 3 has a different shade than quadrant 1 and 4. In addition to that, you have some unique features in this chart, such as the labels of the assets, the ability to execute also has an arrow in it that shows that, okay, if it's going north, that's better. And then the same thing with the completeness of vision, you have a horizontal arrow. And then you see that you have a caption of the chart that says source equals Gartner February 2019 that lets you know where did the user get this data from. So a lot of these subtle features would be hard to recreate in Power BI using traditional means in Power BI. There are ways around that you can do it. I've seen some solutions that appear to be more clunky than what they would be if you were using R. You may be able to take some charts and overlay multiple charts over each other to recreate this type of chart in Power BI. And there are some other hacks that you can do, but the solution is not as clean as it would be if you were using R. So example of that is this situation right here where we're using the data from the LA Lakers season in 2008. And here we have a quad chart that compares the LA Laker basketball players in rebounding and scoring. So if you were looking at this, the first quadrant, that represents players that are high scorers but low rebounders. Quadrant 2 over here represents people who are both high scorers and high rebounders. In quadrant 3, you have people who are relatively low in scoring and rebounding. And in quadrant 4 over here, you have people who are high rebounders but low scorers. So with this being said, you see how we were able to create a situation, a quad chart that mimics the same quad chart that we saw in the Magic Quadrant, the Gartner Magic Quadrant chart. You see that we were able to apply a shade to quadrant 2 and 3. You see that we were able to add labels to the chart, and you see that we were able to do some of the subtle features, such as add a vertical arrow for the scoring and a horizontal arrow for rebounding. Those are things that you can't do natively using Power BI without having to do a whole bunch of hacks, but you can cleanly do them in Power BI, in R, using the Ggplot package that we'll go over. And then you'll also notice that we were even able to add a caption to the chart so that the user would know where we got our data from. So one of the reasons why you want to use R and Power BI to create visuals is because R will allow you to be very expressive with the type of visual you want to do. And in this situation, we can add filters that you typically will add to your visualizations in Power BI. In this situation, we're looking at how the situation plays out if we were only considering home games, but we want to away games. But if we wanted to consider home games, we can click on home, and then the chart will render itself for the situation for home games. So with these charts, you have a situation where your outside filters will propagate to your chart. Now, the feature that you lose is your chart cannot be used to apply filters to other elements in your visualization, but any outside filters can propagate over to your R visualization. Now, this visualization is to go over in the amount of time we have will be it will take too long to do. So what I want to do, the goal in this session is to create a visualization and go through each step of the visual using Ggplot, a package in R to create the visual. And I'll show you the steps to do that. So we can see the visual that we will create in this session. This is the visual that we will create. And the reason why the reason why I chose this visual is because I want to show you some of the things that you can do in Power BI that will get your mind to start thinking. I want you to say, wow, if Ryan was able to do what he did in this visual, maybe I'll be able to apply some tweaks, and maybe I'll do some things to create this this visual that I've been wanting to create, but it wasn't possible before, and using traditional methods in Power BI. So in this visual, what we are doing is we are comparing countries based off of their expenditures on education. And you'll see that in this visual, some of the things that we were able to do is we are able to have a main title and also a subtitle. So subtitles are not a feature in a native Power BI charts, but that is a feature that's native to the type of chart that we're building out here, which is a chart using Ggplot, a package that we will talk about later. In addition to being able to have a main title and a subtitle, we are also able to add a caption to our chart. And captions are very important when you want to show people what was the source of the data that you're using in your visual. So here you are easily able to show them the information by putting that information in your caption. And one of the things that I really like about this, what you can do with our visuals is that as an analyst, I like to do the heavy lifting for the consumers of my reports. I like to be able to control the narrative that I want the visual to have. And you can do that in this situation. If your main goal is to be able to tell your audience a particular thing about your visual, you can do that with annotations using Ggplot. And your annotations do not have to be static. They can be dynamic as they are in this case. You can see in this case that this annotation is comparing the expenditure for the top rate country to the expenditure for the bottom two countries, which is Mozambique and the other country we have here. And you can see that this annotation, it reads out dynamically. It says Lesotho spent 42.6% more than the other two countries did. And if we want to say, okay, what was the situation in 2018? You can click over to 2018 in the same manner you do with any other visual in R, and you'll see that this particular annotation has been dynamically created to show what the situation is comparing Sierra Leone to Togo. So that type of annotation, I think, is very powerful. And I think that this visual right here is a visual that's enough to get you excited about our visuals. And at the same time, it's a visual that we can go over in the amount of time that we have allocated to us. So with that being said, let's go to the code that we need to use in order to, or the code that we need to use in order to create our visual. So we are going to use a Jupyter notebook to describe how to build out that visual. And if any of you want to get into data science or machine learning, AI, what have you, I highly recommend you get very familiar with the Jupyter notebook. The Jupyter notebook to data analysts and to data scientists is almost as frequently used as Microsoft Excel. It is a very powerful tool in that it makes it easy to share your work with others. You'll see that I'm able to not only have live code cells in this Jupyter notebook, but I'm also able to add very rich annotations to the Jupyter notebook to make it easy to share the information I want to share with the user of the notebook. So to start off, the first thing that we will need to do in a Jupyter notebook, let me clear this out so we can start with a fresh notebook. And one more thing before we get started. This Jupyter notebook is hosted in Azure Machine Learning Services. I highly recommend that tool. Having this Jupyter notebook hosted in Azure Machine Learning Services, this makes it easier to maintain, and you don't have to worry about doing all the configuration and the setup work. So if you're interested in having a hosted notebook in the cloud, I highly recommend using the one that's hosted in Azure Machine Learning Services. Okay, so starting off, we will replicate the situation that we have in Power BI. And that situation is that in Power BI, if we want to create the visual, we will click on that, export to our studio, icon, and that will take us to our studio, and it will make available code that we can use to recreate, to create the visual. And the first line that we saw, I believe it was in line 2, was a line of code that read in the data set into the R session. So that's what we're doing right here. And it's important that we use this name data set, because that name is the name that will be used once we put the code back into Power BI. Now, after I read in that data set, I typically like to find out information about the data set that I'm reading in. And there is a nice function in R called STR, which stands for structure. And when you pass a data set to that particular function, it'll give you information, summary information about that data set. And you'll see that here, we have a data frame that has 119 observations. So there were 119 countries in that data set. And you'll see the different data points that were passed into it. We have a country field, we have a total expenditure percent field, and we also have a year field. So after we get that, after we expect our data set, let's look at the packages that we will need to use for this particular visual. Now, this first package is a package that we don't need in Power BI, but I'm just using it in Ggplot. This R package allows us to control the width of the visual in Jupyter Notebook. So this package is needed for the Jupyter Notebook, but it's not needed for the R visual. But the rest of the packages are. And the packages that are needed is one, Ggplot 2. That is the star of this particular session. That is the workhorse package. And Ggplot 2 is a package that is arguably the most popular package in R for data visualization. The GG in Ggplot 2 stands for the grammar of graphics. And basically what that concept it's a concept that dates back to 1970. There was a statistician around that time that developed the concept, and the author of this package, Hadley Wickham, he took his interpretation of the grammar of graphics that was developed back in the 1970s, and he built this package on top of that. So this package makes it easy to take your idea and build a visualization based off of layers, on top of layers on top of layers. So if you want to find more about Ggplot 2, I highly recommend this book right here, R4 Data Science. Now you can see this book is available free of charge. So if you go to this particular URL, and I'll put this in the chat, you will get an online copy of this book for free. Now, this book has a chapter dedicated to data visualization that you can read. That would be a good introduction to the Ggplot package. Highly recommend this book. I feel that this book is the best introduction to R. I highly recommend that if you want to learn R, you use this book to introduce you to it, because you'll learn a lot of good best practices, and it just make your experience much better. So we go back to this visual, to the notebook. You see that there are some other packages that we use. One is a GG Themes package. That is a package that you will see later on that will allow you to add formatting to your chart that is based off of some particular theme. You'll see that later on. dplyr is a very popular package, and that is a data wrangling package. That would be like what M is to Power BI, dplyr is to R. It's a package that makes data wrangling very easy to do. You can do some amazing things with dplyr. The next one is Forecast. Forecast is a package that is used for categorical data. In our categorical data is treated similar to how it is in like DAX, and where that you have a situation where you have some encoding going on underneath the hood, where the categorical data is not really stored in that format, but integer representation of it is stored. to represent that particular data, and then you can do some unique things with that. So we will use that particular package later on in the session. You'll see how. And then the string R package is a very popular package that allows you to do a lot of string manipulation, a lot of advanced string manipulation. You know, you can even leverage things such as regular expressions using the string R package. You can do some amazing type of string manipulation with that package. And then scales package, we're using it in this particular session to for some of the formatting functions that they have in it. Okay, so now we have that. Let's go over get into the best practices for creating these data visualizations in R. So when you create a data visualization in R, you need to make sure before you execute code that is attempting to create the visual, you need to make sure that you have your data in the proper format. You need to make sure that you have all the rows that you need for the visual, all the columns that you need for the visual, or in our community, they call columns variables. And you also need to make sure that any other requirements are met before you attempt to build that visual. If you don't, you'll get a nasty error message, will make the experience not pleasant for the user. And I like to use this basic template to do that. And in this template, we have an if statement that does does the data validation test that we need to perform for the visual. If that data validation test is passed, then R will commence to create the visual. If it's not passed, it will generate a blank chart that has some message on it that is predefined by you. So with that being said, let's go over the methods that we use to create that test and some of the logic that's being used. So before we get into that, I want to first go over this all equal function so that when we get into the portion of the code where we're building out the test, you have a good appreciation of what this all equal function is doing. So if I execute this code right here, if I'm doing the test, it says, is X and Y all equal? In this situation, normally when you see all equal, you probably would expect a Boolean response. But here we didn't get a Boolean response. We got a situation where the all equal function told us that X is not equal to Y, but instead of giving us a Boolean response, it told us some information why they are not equal. Now, on the other hand, if they are equal, we will get a Boolean response. We'll get a true in that case with no other information. We need a Boolean response. So in order to get a Boolean response, when we do our data validation test, we wrap that all equal into with a is true function. And when we do that, you'll see in this situation where S is not equal to Y, it returns false. You're going to see why that's important in this next block of code right here. So for the visual that we have, we need 3 variables or 3 columns for our visual. And the 3 columns of data we need is country, total expenditures percent, and a year. So we need to do a comparison of the columns that's passed to R, and we need to see if those columns meet the criteria that we have for our requirements. And we do that first. Sort is important. We had if we were trying to do the comparison, and if we said that the columns in the current columns was total spent percent, country, and year, not in alphabetical order, then we did that comparison. Even though the 2 variables have the same variables in it or the same columns in it, it won't pass the test. So we need to make sure that we apply a sort to the column names before we do the comparison. And that's what the sort function is doing. And then with the required columns variable, we have the list of the required columns in alphabetical order. And then the second thing we do right here, we do a comparison between the 2 to see if they're equal. And if they're equal, which they are in this case, you'll see that the column test will evaluate the true. Another thing that we need in this particular data set is that if you recall from Power BI, we were able to do this analysis based on a year. So there were years, I think it dated back to 1980 up to 2018. So we need to make sure that the data set that's passed to R only contains 1 year worth of data. And we do that with this unique function. This unique function will return all the unique records in that year field. So after we run that, we go down to the the next cell, and this is the basic structure that I showed you earlier, where the if statement is first doing the data validation test. If it passed, then in this situation, the code that you want to create the visual will be where you see print and pass test. That will get executed. Otherwise, a blank pop will be generated with the message that we see here. The data supply did not meet the requirement of the chart. So if we execute this code, you'll see that after it runs, it prints out pass test. So our data validation test passed. So now that we got that piece of the code explained, let's explain what goes in this session right here. The code that actually generates the visual. One of the nice things about building a visual in Power BI using R is that if the data that's passed to your R visual doesn't contain everything you need. Say for instance, you may have a situation where you need to add a calculated column to your data set that is based off of some calculation that you can't do in DAX, that you can't do in M, but you can do in R. That will be the case a lot of times when you're dealing with some advanced analytics. Well, you don't have to go with the data that was passed to R. You can go with that data as a starting point, and you can add calculated columns to it. That's what we're doing in this situation. And you'll see that with the data set that we got passed to it, there are some things that we need to do to our data. One, we need to do a ranking of our data. Now, I know that our dance professionals in this group will tell me that you can do the exact same thing in Power BI, which you can. Yeah, you can do that with DAX. But what I was trying to do in this situation is show you that you can create a calculated column. And I didn't want to get too complicated with the calculation, given the amount of time that we have in this session. But here you see that we're using a window function in R. Yes, R has window functions in the dplyr package, and we're using the window function to do our ranking. And we're also using the factory order function from R that allows us to determine the order of our country. So just like in Power BI, how you can do a sort on a column based on another column, this is essentially what's being done right here. With this factory order function, we're saying that we want to sort the country column based off of the rank column. So we're doing that in that particular line of code, and that's going to be used by the visual. You'll see that later on. And then the last line of code, we're creating a new column, a new calculated column called a callout column. And that column will be used in our visual later on that will allow us to color the country that ranks #1 using a different color than the other countries. And then in our situation, we only want to look at the top 7. So we use the filter function from dplyr to filter out everything and only keep the records that are ranked 7th or lower. Now, if you want to learn more about dplyr, more about some of these data viz stuff, that book that I recommended earlier, R for Data Science, recommended read. Highly recommended read. So if we execute this code, you'll see that we have the data set that's needed for our visual. Now, if we scroll down, we got our data set defined. The next thing we want to define are the titles of our chart. And in this situation, we're defining our main title, our subtitle, and our caption. And just like with Power BI, how you can use a DAX measure to dynamically label to create dynamic titles for your chart. You can do the exact same thing with our visual. You can create a situation where your titles are not static like the main title is, but it's dynamic using whatever method you would like to use that's available to you in R. As you see in the situation for the subtitle, we're using the paste function in R to dynamically build out the string that we need for our subtitle. Now the paste function, that's like a concatenate function on steroids. And it allows you to concatenate, if I can say it correctly, concatenate a group of strings together, and it allows you to specify what you want your delimiter to be. In this case, we want our delimiter to be an open space, and we identify that with the set argument. So we run that, we have our titles. So now the next thing we need to do is we need to define some other variables that we will use to define or to create that dynamic annotation that we mentioned. Now, with our programming language, creating these variables are pretty they're relatively easy to do. So the first thing we want to do is we want to find the country that is ranked #1, and we want to assign that to a variable. And that's what we're going to do in these next 2 lines of code. In the first line of code, I'm just going to give you, we're going to use that. We're going to run this cell so you can see how R operates. Now, in this situation, the plot $rank, we're referring to the rank column in our data set, which is a data set that contains 3 variables or 3 columns and 7 records. Now, we want to see the situation where the rank is equal to 1. We don't get one response, but we get a response for every single observation or every single row in our data set. So it would say, if we go up to that data set real quick, you'll see that is the first row equal to true? No. Second one, no. But the last one is yes. So with that being said, we can use this particular, what they call a Boolean character vector. Now, again, if you want to learn about all the different data types that you have available to you in R, you know what book I recommend. But in a very quickly, what a Boolean character vector is, it's a vector of just trues and falses. So in this situation, we can use that Boolean, the Boolean vector, and pass it to this the country field, and we can use that to subset the country field. So what will happen is, if we pass it to the country field and use brackets, for our subsetting, every situation where that Boolean vector evaluated true will be kept, and the false records will be disregarded. So we'll have end up with a situation where only the #1 ranked country will be assigned to that variable. So that's a way, that's a proper way to subset in R. And when I say subset in R, you can think of subsetting records in R as the same as the same as filtering your records. So this is a very popular way to subset your data in R using base R functionality. So once we define that, we need to define other dynamic parts of our chart. We need to define the min country and also the max country and the min expenditure and the max expenditure. All those variables are going to be used when we create that dynamic annotation that you'll see later on. And I think that looking at this, you can see, based off the explanation I gave about subsetting your records in this cell right here, along with, I'm assuming, your basic understanding of programming, creating these variables are pretty straightforward. So we scroll down, the next thing that we're going to do, and the last thing we're going to do from a standpoint of defining the dynamic portions of our chart, is we're going to create a variable that has the annotation. And we'll do that with this cell right here. Now, one of the things I like about creating visuals in R is that, yeah, it's code-based. You don't have that nice GUI that we're used to in Power BI, that, the world-class GUI that we're used to. But with code, you're given so much freedom to do exactly what you want to do. So with this annotation, we're not forced to accept the formatting that R would give us or that R think is best. We can customize R to give us the response that we desire. So in this case, we're building out this annotation. We can tell R that, okay, this is the string that we want you to dynamically build. But with this string, we want to control how this string is wrapped. So if this string end up being a very long string, we can tell R specifically that when it hits character 25, well, with the 25, I want you to take the remaining and wrap it around and take that code or that string and put it in another line. And then if that second line reaches 25, it will wrap into a third line. And they'll keep on doing that until the string is finally built out. That type of customization, I think, is very powerful, and it allows you to build a type of visual that you really want to build. And with with the string wrap function, that's not the only type of customization that you can do with your annotation. You can also say, I want the first row to be indented one way, but then all subsequent lines to be indented another way. You can get you can customize the way your annotation is printed out. There's a lot of options that you can use to customize it. So with that being said, we're creating the label that will be used for our annotation. You'll see that later on. So now we're going to get into the part where we're building out the visual. We built up to this part all the code that we need to build the visual. Now we want to get to the point where we can start building actual visual. And again, in this first line up here, the options for the code that's going to be in Power BI, this is not needed. This is just needed for, to control how the visuals that we're going to create, how they display in the Jupyter Notebook. So the first thing we need to do is we need to initialize our chart by initializing a function from the Ggplot package called Ggplot. And we initialize that with the data that we want to use for our visual, that we want to be made available to all layers of our chart. And we also define our aesthetics. That's what this AES function stands for. So when you think of aesthetics in Ggplot, think of mapping your variables or your columns in your data set to an aesthetic on your visual. So in this case, we're mapping the column country to our x-axis. We're mapping the column total spent percent to our y-axis. We're mapping the fill to the call out to fill, and fill, you can think of that as color, because fill is like the color that's inside of the bars in our Ggplot visual. And then a label that will be used to add labels to our column chart. But as you know, at this point, you see that we initialize our Ggplot, but there's nothing there. And that the reason why is because we haven't defined any layers just yet. So with that being said, we need to start telling Ggplot, okay, we have this data that we want to use for our chart. Let's build some layers on top of this. Let's build some layers so we can actually have a visual. So that's what we're going to do in this next line of code. In this next line of code, you'll see we have a situation where we add a layer, and this layer is a geom bar. Now, geom stands for geometric object. So there are a bunch of geoms available to you. You have geoms that's available to you in Ggplot, but then there's a bunch of helper packages that you can use along with Ggplot that has a lot more geoms that you can use. So you can think of a geom as the actual shape that you want to plot on your chart. In this case, we're doing a column chart. So if we execute this code, you'll see that we have this visual right here. Now with this visual, you see that we had to pass in an argument to the geom bar, stat equals identity. And the reason why we had to do that is because the default is to do a count based on the grouping. So it'll do a count of the rows in that particular grouping. That's not what we want. We want the actual value. So right there, that's what it gives us. It will base the geom bar off of the value that's in the total spent percent column. Okay, so another thing about geom, you see that the geom bar, only aesthetic we had to supply was the stat. We didn't have to supply the aesthetic for the X and the Y axis or the fill because those were inherited from the ggplot function. Okay, so we got that. So now we're getting close to the visual that we showed you earlier, but there's some stuff that we need to add to it. Next thing we're going to add are the labels. And with the labels, what we did here was we added labels to the chart. And this is another example of how much customization you can easily do with R and via the ggplot package. Here, because we're going to have annotations on our chart, and we can go back to the visual so you can see what I'm talking about, not the quad chart, but this chart right here. You'll see that we have this annotation over here. The Sierra Leone spent 49.2% more of their expenditures on education than Togo. So this, we want to make sure that this particular annotation does not overlap or overlay the label from the visual. So in order to ensure that that won't happen, we use the nudge underscore Y argument, and we say we set that to 0.05, negative 0.05, and what that will do is it will nudge that label down 0.05 units, and it will ensure that our labels are inside the column bar, inside the bar chart, so that it won't overlay with our annotations. Okay, so the next thing that we do with this visual, and then we're building up. You see how we're able to add layers on top of layers, how expressive we're able to be with our charts, and how easy it is to add what we want to our chart. The next thing that we do is we add a scale to our chart. Now, to make it easier, I will reformat that. So we add a scale to our chart, and we set our scale between 0 and 0.75. I think that's important because, like even in Power BI, you may have a situation where you have a chart and you can, do like we're doing here, where you can go from, year 1 to year 2, and the scales may be different in both years. So visually, it may look like some is totally different than what the actual situation is, because the visual that you're looking at is on 2 different scales. So I think that if you're doing a chart where you're comparing different years, that it's important that you keep the same scales between the years. And you can do that by setting your scale here. Now, you'll see that we have the scale argument, function that we're using here is the scale underscore Y underscore continuous. The reason why we're using that scale is because our chart is using a continuous number. Now, if we were using a different data type in our Y-axis, then the scale that we'll use for that would be based on the data that is represented in that particular scale. So we set that. So now you see we have a situation where we have our a fifth scale between 0 and 0.75. So the next thing that we'll do is we flip our chart from a bar chart to a bar chart. And you see how easy that was done. We did it by using this core flip function, which all it did was it just, reverse. It made our S-axis, our Y-axis, and so on and so forth. And in doing that, it allowed us to go from a vertical bar chart to a horizontal bar chart, which is a better chart to use when you're doing comparison. Much better than the exploding pie chart that my friend at Guy in the Cube like. Okay, so the next thing we do is now we get into the line of code that we're going to use to add annotation to. And you see that that's done right here with this annotate function. And in the annotate function, we tell it the type of annotation we want to do, which is a text annotation, and then what text we want to use in our annotation. But notice here with our S and Y, how we're able to be dynamic with it. we can say that we're giving our dynamic information on how we want to position our annotation. So in this situation, we're saying that we want to base the S position on the country, and then we want to base the Y position of our annotation on the mass expenditures plus 0.1. So doing that ensures that our annotation is positioned outside of our horizontal bar chart. And if you, so this, imagine, look at this and this, start getting your creative juices to run. You see that we can have this annotation dynamically placed anywhere we wanted to. If we wanted this to be placed in the third position instead of the first position, we can do that through code. We can dynamically determine the position of the annotation, and it's not a situation where we're doing something in Power BI where we may take a text, not a card, a visual, and this, statically place it over some chart that we want to have an annotation on. That can get pretty clunky, but with R, you can say, okay, I can dynamically determine based off of whatever logic I want to use the position of our annotation. Extremely powerful. Another thing I want to point out before I move forward is that you notice that this, even though this appear, it looks like it's the Y axis, we're referring to it with the S, argument and annotating, the same thing with the Y. Well, even though we did that core flip function, even though we use that in order to change the position or the layout of our chart, the way the code is referring to the X axis and the Y axis remain the same. So that can be a little confusing, but know that to this R code, it's ignoring this core flip. The core flip is only for visual purposes. Okay, so the next thing we want to do is here in this line of code, we're adding our labels. So once we add our labels, you'll see that we have a situation now where we have our government, our main title, subtitle, and caption. That caption is super important when you're doing some, type of analysis where you're using data that you need to give credit to. So in this situation, the data that I'm using in this example came from the data bank, the World Data Bank. I need to give them credit for this data. This is not research that I did. I didn't acquire this data. The World Bank acquired this data, so I need to give them credit for it. And R makes it easy for you to do that via a caption. And that is not, I know we have the ability to do dynamic titles in Power BI, but the last I checked, we're not able to do subtitles in native visuals in Power BI, and we're not able to do captions. We will need to do some sort of hack in order to add that to a Power BI visual. And that's not the case with Ggplot. The next thing we want to do is we want to remove some information from our chart that's not needed. We remove the labels for the axis, for the S axis and the Y axis. It's clear in this data set that, if I scroll up here, it's clear that this on the left, our Y-axis is Zimbabwe, Ethiopia. That's a country. We don't need to tell our users that. They already know that information. And the same thing with our axis on our horizontal axis. We know that it's measuring government expenditures because of our title. So one of the things that is a rule or a best practice when it comes to data visualization is that you want to be a minimalist. You don't want to include unnecessary information. So with the S lab and the Y lab, we're able to remove the label because the lab and S lab stands for label and the Y and Y lab stands for label, and we're setting our label equal to null. And then this next line right here, we're removing the legend. So up here, you see that we have a legend right here for fill, and that's not needed. All we wanted to do was highlight the #1 ranked country, and we don't need a legend for that. So with the guides function, you can easily remove a legend for a particular static using the guide function. So in this situation, the call out is related to the fill argument. You see that right here. You see that's related, to the field variable or the field column. So here we're saying that we don't need that legend, so we can remove it by setting equal to false. Okay. So we're almost done. We're getting to the visual that's almost production ready, and that it's almost at the level that we want it to be at for Power BI. And there's just a few more things we need to do. And this line right here, I think this is like a very good feature of Ggplot. One of my favorite features about Ggplot, and that is the ability to add themes to your chart. Now, I'm a Christian, and in the Christian community, one of the popular sayings in Christianity is, before you do something that you're questioning whether you should do it or not, you would say, what would Jesus do? Well, we're in the data viz profession, and one of the most popular data visualization artists or visualization, lack of a better word, experts is a guy named Stephen Few. Stephen Few has been doing data viz for a long time, and Stephen Few and another guy named Edward Tufte, they are to the data viz community that the people in that the Italians, Marco Russo and Alberto Ferrero, are to DAX, and that someone like Isabigana is to T-SQL. You know, if you hear them say something, you know that, okay, what they said is golden, and even though you may think against it, you know, you probably don't want to go against it because they are more likely know more than you do about that particular topic. So with that being said, Ggplot gives you the ability to say, what would Stephen Few do to this data viz? And Stephen Few, as I mentioned earlier, he's like a minimalist type of guy in that he thinks that everything that you put on your chart should have meaning. You shouldn't have a lot of random colors on your chart. You shouldn't have a lot of random things in your chart that's not really, you know, that doesn't have value to it. So with this one function, you can add that to your Ggplot script or your R script, and it will reformat your visual using principles that Stephen Few would use. That's in one line of code. Really one function, really less than one line of code. And there are built-in themes in the Ggplot package. The theme view theme comes from the package, the Gg themes visual package, but there are other themes that's available to you. You have one for Edward Tufte that I mentioned earlier. You have one for the publication Economist, who you know, that publication is known for their visuals. You have one for the New York Times. So you can use one of their themes to reformat the non-data elements of your chart to present the data like it will be presented if Stephen Few was doing. So with that being said, I can take a quick pause right now because we're running. We have some good time. Do we have any questions before we move forward?
Hi. Yeah, we have a couple questions in here from some people. Apologies if you've already answered them, but the first one here is from Chuck. Do our visuals work in Power BI report server? If so, does R and all necessary packages need to be installed on the server?
You can create our visuals in report server, but the process is different than what it would be with Power BI. Essentially, what you would be doing in that type of situation will be you will use R to create a image, like a ping file or of an image, and then that ping file will be displayed in report server. You won't have the same type of dynamic experience that we have here. So it's yeah, you can do it. There are some hacks that you can use to do that, but the process is totally different than what it is in Power BI.
Cool. Okay. Does our visualization support direct query mode?
That is a good question. Let me follow up with that. I believe it does. I don't think anything about direct query will prevent R from being an option, but I need to follow with that. You know, if you had a gun to my head and you say I had to pick an answer, I would say yes, you can, but I need to validate that. So if I can do a follow-up blog post on this particular talk, and I'll answer that question.
Sure, that'd be great. So last one that's coming up here is, can an R visualization still have drill through to the detailed data?
now you can't do it the same way that you do it with a native Power BI visual. What I like to do is I will have like a proxy visual on the sheet that will serve in place of our visual, that wherever drill down functionality I want R to have, I will put it in that R visual. I mean, not in R visual, but in the Power BI visual, that'd be a proxy for it. So I would, do my drill down using that and not, R. You can't do drill down with R directly, but you can use a proxy visual to do it. Okay, so any more questions?
That's all I got for right now, but if anybody else has anything, feel free to type it in the question pane there.
Okay, perfect.
We've got a couple minutes left.
Yeah, perfect. Yeah, we good timing. So the last thing that we need to do is, you see that in this our visual, we have a situation where we want to change the formatting of some elements in our chart, with it being like our main title, our subtitle, and our what's the main title and subtitle is what we want to change. We want to have that centered, and we can easily do that, as you can see if we scroll down a little bit, using the theme function. Now the theme function, it allows you to control, it gives you a lot of custom control over the different components of your chart. So you'll see that we have a component that the two components that we're adjusting in this example is our title and our subtitle. We want to center it. So with each component, for most of them, there is what they call an element function that you use to modify whatever component you want to modify. And most often the element function that's being used is the element underscore text. And you can look in the help in R to get the parameters that's available to you. But with the element text function, you can use that to control multiple things about that particular component. In this case, we want to control the position of the title. And we center text in R using the hgest function. And the H stands for horizontal. So by setting that to 0.5, that will center it. If we have that value equal to 0, it will justify it to the left. If we put it at 0.5, which we did in this case, it will center it. And we gave it a value of 1, it will right justify it. So no, you can use anything in between. So you'll see that in doing that, we now have a situation where we have our title centered. We have everything that we need in this chart that is production ready. So now that, if we were building this out in our studio, you'll see that if we go to our studio and our virtual machine, you'll see that the complete script is here. Hit no. So you'll see that once we get our script functional in our studio, all we need to do is copy, everything, all the code that's below record 9, line 9, and we will paste that into Power BI, into this R script editor. And once we do that, now we have the R code that's needed to create our visual, and we have all the interactivity that we're used to. So that we expect. And to publish this is the same as before, in that you need to publish any visual that you create. You will need to publish this out to the service, and when you do, you'll see that you have a situation where you have an interactive visual in the service that's based off of the R visual that you created. So let me get rid, so you can see it. Yeah, so here, so this is that same visual in the service. So you'll see that the interactivity that you have is the same interactivity that you had when you were developing the script in the desktop. The last thing I want to show is that, and I can look for this on the fly, is that you notice that you notice that we were able to use or deploy that visual out to the service. And the reason why we were able to do that was because the packages that are needed for that visual are also in the service. So when you're creating a visual, you need to make sure that the packages you're using are also packages in the service. And you also need to make sure that the packages that you're using or that you're using for development is the same version that's being used in the service. You don't want to base your development on some new version of the package, and that package is not the version of the package that's available in the service. You'll run into errors when you do that. So if you go to this website, and this website is included in the README, and I'll also include this in the chat, you'll see that you can use this particular website to get the list of packages that's available to you. So scroll down, you see all the list of packages. The last thing I want to share is that this GitHub repo that have the information that I mentioned, and plus some other information that will help you out with development that you can use to recreate the situation that we have here. And again, if you're interested in what was talked about today, I highly recommend you check us out at Blue Granite. We're going to have a blog series on this coming up where we will not only go over how to do our visuals, but how to use R and Python and other advanced scenarios within Power BI. If there's not any questions, thank you all for attending.
Hello again. I hope you've been enjoying everything the past virtual summit has to offer. I wanted to take a minute to remind you that all of the conference sessions and content will be available for 12 months on demand, so you'll be able to catch up on any of the sessions you missed at any time throughout the year. You can also visit the exhibit hall on demand after the conference has ended and leave a question for our sponsors and exhibitors. And now, back to your past virtual summit program.